Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on digital communication. These are the topic of discussion for today's video. Firstly, I will define what is scrambling. Okay, so for some, basically they thought that scrambling is actually a part of encryption, but it's actually not. So basically, scrambling is intended for unauthorized user access the data and also time synchronization. So this is actually the key purpose of scrambling. Next, I will explain how scrambling actually works, with a diagram. Last but not least, I'm going to highlight the difference between scrambling versus encryption. So basically, all this will be the objective of this video. Guys, if you have any question regards on this discussion, please send me an email, okay? Or if not, I actually prefer you guys to send me through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, just give me a few seconds. Help me. Press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's kickstart today's discussion. Okay, firstly, let me explain what is actually scrambling. Scrambling actually refers to a signal processing techniques that is used to randomize or pseudo-randomize a digital bit stream before transmission. Over here, you can see that this is actually a scramble. This is the descramble. Scramble is at the transmitter side. Descramble is actually at the receiver side. This is the original data. So after they go through the scramble, another new set of data will be available over here. And this set of data will be sending over to the receiver. So from here, you can see that the receiver received this signal and basically go through the descramble to get back the exact so-called signal that is intended to send over here. So basically, this is actually scrambling. So what is the main purpose of scrambling? Okay, so the key purpose is to improve transmission reliability and efficient, but not on the security, which I will highlight later on. Scrambling actually modified the data sequence without changing its actual information content. Okay, so basically you can see from here, basically this is the original data. So scrambling actually modified the data sequence, okay, but without changing its actual information content. Why? Because on the receiver side, I actually have this descramble to so-called reassemble back the original signal that is intended to send. Okay, primary is to achieve specific system performance goal, such as preventing long sequence of identifiable bits, for example, long ones or long zero. So basically, this is to establish time synchronization also. Okay, basically, this can cause synchronization problems in receiver. Okay, so basically, this is for scrambling. These are the two purposes of scrambling. The first one, they actually can prevent unauthorized access of data. If you still remember what scrambling do is, this is actually the original data. So after scrambling, it actually changed to another set of data. You can see that these two set of data, they are actually not identical. So therefore, when we actually change to another set of data, if let's say the unauthorized user, they will not have any means to convert back to the original data. So basically with this, they actually prevent unauthorized access of data. So this is actually the first use of scrambling. Next, the second use will be avoid long runs of identical bits. For example, over here, you can see that I actually has a long runs of 0 and also a long runs of 1. So after scrambling, okay, the message format can look like this. And with this, I actually resolve the issue of synchronization. Because over here, you imagine, if there's too many 0, you probably will lose the direction. But once I actually scramble into this format, then the data will be remain intact. One thing that I need to highlight, we need to have a balanced numbers of zeros and one. What does this mean? For example, this is actually the original data. Okay, from here you can see that they have 40 and 41. So after scrambling, okay, I also need to have 40 and 41. So this is actually the meaning, balanced numbers of zeros and one. Okay, so remember also the descrambling, okay, is actually happen at the receiver, and basically the data will be able to recover back the original message. Next, I'm going to quickly explain how a scrambling actually works. Okay, basically the input binary data is modified by a scrambling algorithm. Okay, so basically this is actually the original data over here. This is actually a scramble. Okay, so we have many possible configuration. Okay, you need not to be tapped at this so-called register 3. I can tap at register 2 or even at register 1 or at register 4. So basically this is actually unique. So when the intent receiver, they know how you actually scramble the data, and they will be able to recover back the original data. So this is the meaning of scrambling algorithm, which the user, okay, on the transmitter and the user at the receiver, they agree, they know the format, and they are able to so-called recover back the original message that is actually sent by the transmitter and then reach the receiver. So this is the key purpose of scrambling. Next, the scrambling output look random, as I told you that after going through the scramble, they actually change the whole format of data, okay, but it's actually deterministic. Okay, the receiver can use a descramble to reconstruct back the original data. I like to highlight this. Unlike encryption, scrambling is not meant for security. It is for signal integrity and synchronization. Okay, so basically this is a quick explanation how scrambling actually works. Before I continue the advantages and also the disadvantages of scrambling, I need your help, guys. I need you to help me by like this video. If you have learned something from this video, I appreciate you can help me by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. Advantages and disadvantages of scrambling. Let's come to the advantages first. Okay, so firstly, they actually improve synchronization between the transmitter and receiver. Next, they also have some form of error detection. Why? Because they avoid repetitive patterns, for example, repetitive 0 or repetitive 1. Next, the key advantage is it does not increase the numbers of transmit bit. So these are the advantages of scrambling. Come to the disadvantage, okay, the error can be multiplied. A single bit error may affect the multiple bits after descrambling. Next, they also add some form of complexity to the system, as you can see from here. So basically, they actually add this scramble, okay, and also descramble at the receiver side. So therefore, they actually add some form of complexity to the system. Next, randomized sequence may sometimes reduce predictability in testing. Next, I like to do a quick comparison between scrambling and encryption. So over here, this is actually scrambling, this is encryption. The key purpose for scrambling is basically to provide some form of synchronization and also to robust the signal integrity. As for encryption, they mainly take care of security and also the confidential of the data. Next, in terms of the domain, scrambling actually changed the digital signal, while the encryption actually changed at the digital data, which is the 1 and 0. Coming to the recoverability, scrambling is actually very deterministic and they can easily descramble at the receiver side. As for encryption, they require maybe the private key, the public key, and in fact, it's a very complex algorithm. Impact on bit rate, there is no increase or no decrease in terms of bit rate. But for encryption, okay, they may increase due to overhead because you add extra bit and therefore you actually require more time to send the same amount of data. So therefore, there is some form of impact on bit rate. Let me explain a little bit more how the scrambling actually works. So on your left is actually the scramble, on your right is the descramble. So this is the original data that I want to send over to the receiver. So after scrambling, they actually arrive at another set of data. So this set of data will be sending over through the communication medium to the receiver. So at the receiver side, they will actually descramble and arrive back the original data from the transmitter. Let's take a look on the scramble first. So these are all the shift register, which means that the data initially come from over here. They will move to the first register, which is known as D1T. So this will be the data D1. Okay, the data at T, what will be the data? After that, they will shift up. Okay, so this data will shift up. After the second time, again, the data will shift up, and this thing continue on and on. So basically, this is for the scramble. How can I actually arrive at this equation? So this T over here, you can see that this is actually exclusive OR. Okay, so the truth table is actually over here, which I will later on explain. So this is actually an exclusive OR. So from here, you can see that S exclusive OR along this path here. So this path, what will be the value? This is actually the data at D5 and also the data at D3 exclusive OR. So basically, this is the data at the D3, and this is actually the data at D5. Okay, so from here and from here, they actually do an exclusive OR. So basically, over here is D3T exclusive OR D5T. Okay, so basically, this will be the data set over here. After that, they will do a exclusive OR with S. So basically, this is how I arrive this equation. Let's come to the truth table first. Exclusive OR. So from here, you can see that if the data is exactly the same, the outcome will be 0. If the data is actually different, you can see that the outcome will be 1. This 1, the data are the same, so therefore the outcome is 0. So basically, this is actually the truth table for exclusive OR. Let's move back to this equation again. My intention is to make this S as a subject, okay, which means that for plus, you can easily shift them to the left-hand side. But for this case here, it's not so easy. So if I want to remove away all this, I need to do a exclusive OR with the same set of data. Then I will remove all this. And basically what left will be just S. So what I need to do is, you can see from here, I need to do this exclusive OR. Okay, so once I do this exclusive OR, because the same data, I will get 0. So all this will be removed away. So this is what I want to do. All this will be removed away, and therefore I only have this S term over here. So over the left-hand side, I need to add this, so that I will add on the right-hand side, same thing over here. And this whole thing will become 0, and therefore I actually can arrive at this equation. So this equation SK is actually equals to T exclusive OR data at 3 and data at 5. So basically, I can also so-called put a bigger bracket. Okay, so I just take the T over here. So this will be the 1. Okay, basically, what will be the data at D3 and what will be the data at D5. Okay, so on my next video, I will give you a real example in order to understand this better. So this is actually the data that is actually at the S. So now I'm going to show it to you. The data at R will be equals to the S. Okay, because I am the intent receiver. Okay, basically you can imagine that all this algorithm I can change. But because I am the intent, so-called the receiver, so therefore I know the scrambling algorithm. So therefore you can see that they are exactly the same. Okay, so how I get this R over here? Okay, so this R again, you can see that will be T. Okay, from here you can see that will be data at 3 and data at 5. And therefore I can get this equation. And again, I just want to take a common factor, which is T. So basically from here, you can see that the data at S and the data at R, they are exactly the same, which means that I can actually convert so-called the scrambling the data to another format and basically send this format up over the communication channel and reach the receiver. And basically once they go through this descramble, you can see that the data at S is exactly the data at R. So this is the key purpose of scrambling. Okay, so they are not really putting some form of security, but they scramble the data into another format which prevent unauthorized user to understand the message. And also they basically provide some form of synchronization to ensure, okay, basically synchronization will be able to happen for this transmitter and receiver. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.